Good day, my name is and I will be your tutor for mathematics today. Our topic that we'll be covering for today is mensuration. You have been learning mensuration from your primary school, your junior school, and now you're going to find it here when you're in senior school. So, mensuration, as some of you maybe have forgotten, it is the study of lengths, areas, volumes, mass, and densities of different solid shapes. We have different solid shapes that we are going to be talking about in this topic. So today, let's start with the circle. As you all know how a circle looks like, here is my circle. The circle is divided into so many parts that we're going to learn about today. So before we get on to anything, I hope all of you know how a circle is. The circle, it has what we call a diameter. As you can already see how I've named my diameter on the board. My diameter runs from one point of a circle to the other point of a circle. So how can we explain a diameter? How can be our definition of the diameter? If you look onto this side, we have different definitions of these types of a circle. So what can we say a diameter is? A diameter is a straight line from one point to another, passing through the center of the circle. So as you can already see how my diameter, I have named it. It's from one point of a circle to the other point of a circle. And where is it crossing? It's crossing on the center. You can't say my diameter just because I say it's from one point of a circle to another. You can't say this is my diameter. Why is it wrong? Because it's supposed to pass through the center of a circle. So it's a straight line that passes from one point of a circle to another point of the circle through the center. And where is our center? Our center is here. So this is our center. And then next, after the diameter, we are going to talk about the radius. As you have already seen, I've named my radius. Here is my radius. So what is a radius? Radius is half of a diameter. As I already said with my diameter consists from one point of the circle through the center to the other point of the circle. But the diameter is going to be half of that. It's going to be from one point to the center of a circle. That's why we say half of a diameter. And then next, we have what you call a tangent. What is a tangent? As you already see on the board, here is my tangent. Here is my straight line that is just passing through my circle. So what can we say a tangent is? A tangent, as we've already named on the board, we say is a straight line that touches a curve but is extended and does not cross the point. What are we talking about in this point? It's a straight line, it just touches the circle. It does not go into the circle, no. All it does is just passing through the circle and touch it. And that's what we call a tangent. And then next, we're going to go on to what we call a segment. As you can already see how my segment is not this line, no. As you can already see, I haven't pointed this line as my segment. My segment is this portion. This portion. So how can we explain what a segment is? A segment is a region bounded by a chord and they are subtended by the chord. What are we talking about? Maybe you can understand better when we explain what a chord is. What is a chord? As you can already see, I've drawn a line from one point to the other. It's not passing through the center, so don't get it confused and say it's the diameter. So it's just from one point of the circle to the other point. It's a straight line, remember? And we just named that line a chord. So how can we explain what a chord is? Let's get back to our definitions. A chord is a straight line segment where endpoints both lie on the circle. The endpoints of the chord both lie on the circle. So you might confuse a chord and the diameter. Remember what we said the diameter is? From one end of a circle to the other end of the circle, passing through the center. But the chord, what do we say? The chord is a straight line segment where endpoints both lie on the circle. They both are on the circle, but it does not pass through the center. So that's what we call a chord. So a chord, you can't draw a line like this and say it's a chord. Why? Because it does not lie on both sides of the circle, both endpoints of the circle. So that's why we can say this line is a chord. So let's go back to our definition of segment. We wanted to understand what a chord is before we understand what a segment is. A segment is a region bounded by a chord and they are subtended by the chord. So it's just a part that, you remember what we said a chord is? It's just that part that is subtended by a chord. So far we've learned about the diameter, the radius, a segment, a chord. Next, and also a tangent. Next, we can go on to what we call a sector. As you can already see where I have named my sector on the circle. You can see, right? So, if you look at where the sector is, I haven't shown any line on the sector. I just drew this part as the sector. So how can we explain what the sector is? Let's get back to our definitions. A sector is part of a circle enclosed by two radii. Radii is as we were already talking about a circle, we are talking about the sector. And what did we say a sector is? To our definition, we said a sector is part of a circle enclosed by two radii. Radii is a plural word for radius. I guess you can already learn that in English. So radius, it's 1, radii is 2. So, as we already said in our definition, it's part of a circle enclosed by a radii. As you see, there are two radiuses here, which we call radii now, right? Another one is here, another one is here. That's why we say it's a part of a circle enclosed by two radii. And what did we say a radius is? A radius, we say it's half of a diameter, right? Half of a diameter, we mean that it's touching from one end point of a circle to the center. As you can already see these two radii, you see that one point to the center, the end point of a circle to the center. When they join, what do they create? They create what we call a sector. So next, now we can talk about the sector angle. And wherever they're joining, there is an angle that is created there. And that angle, we call it a sector angle. So next, we are going to talk about an arc. As you can already see, as I've named on my circle, that my AB is the arc. My AB is the arc. So what do I mean? I mean that from A to B, this part is an arc. And what do we say an arc is? It's a portion of the circumference of a circle. Maybe some of you don't know what a circumference is. Circumference is the distance around the circle. So what are we saying an arc is? An arc is a portion from the whole circumference. So we have two arcs. We have what we call the minor arc and the major arc. In this case, as I've already drawn my circle, in this case, my AB is the what? Is the minor arc. It's just a small portion of the circumference. And the other part that is leaving is what we call the major arc. So this, my AB is the minor arc, and the bigger part is the major arc. So thank you. Next on our lesson, we're going to be learning more about the circle. Welcome back to the lesson of mensuration. So before, we were learning about a circle, parts of a circle, and all the other things. Now we're going to get onto calculations. So these calculations, the reason that we're learning all those definitions is for you to understand how these calculations are going to work. So in a circle, we have what we call the circumference. And which we said before, what the circumference is, we said is the distance around the circle. So how do you calculate the circumference? If a question comes to you and say, what is the circumference of the circle? What are you going to use? You're going to use C is equals to pi d. Some of you might know what pi is. Pi, in your calculator, scientific calculator, your pi is this one. Here it is. After HYP sine cos 10, that's your pi. And if you press it in your calculator, what are you going to see? It's going to give you these values: 3.141592654. Some of you express your pi as 22/7, which is still the same thing. But unless stated on your paper how you express your pi, it differentiates. You can just press on the one on the calculator. You can use 22/7 because your paper one, you don't use a calculator. So C is equals to pi d. That d stands for what? Diameter. And what do we say the diameter is? Is the end point, one end point of a circle to the other end point of a circle passing through the center. So it's going to be pi d. It's going to be 22/7 times d. And your d, I want to state what your d is. Your d can be 3 centimeters. Your d can be 5 centimeters. So it's going to be 22/7 times 5. Or what you can use is what? 2 pi r. As I've already written here, 2 pi r. So that means it's 2 times pi times r. And what is your r? Your r is the radius. What do we say the radius is? One end point of a circle to the center. So, for example, the question will come like this. They'll draw a circle for you, right? They'll draw a circle for you. What are they going to do? They're just going to draw a straight line and say 5 centimeters. And the question is going to come to you and say, calculate your circumference. Calculate the circumference of the circle. What are you going to do? You're going to know that circumference is equals to pi d. Circumference is equals to, what is your diameter in this case? Here is your diameter. Remember what your diameter is? One end point of a circle to the other. Right? So what are you going to say? You're going to press your pi in the calculator, the multiplication sign in the calculator, and 5. And it's going to give you 15.707963227. And remember that in maths, all figures are supposed to be 2, 3 significant figures. And I hope on the lessons before you were taught how significant figures, how do you turn something to a certain significant figure. So in this case, to 3 significant figures, how is it going to remain? It's going to remain as 15.7 centimeters. Not just 15.7. The units are important. Why are they important? The question can give you units in centimeters, but want your answer to be in meters. So unless what the question states what it wants, that's when you can convert. And as I already know, you passed through a topic called the ratios, and we had what you call simple ratios. Simple ratios, the one that you express as 1:n. 1:n, that you know that 1 centimeter is equals to 10 millimeters. So if you know that, you can convert any value to any value that is needed. Next, we're going to learn about the diameter. As I already told you what the diameter is, if you want to express it in terms of radius, what are you going to say? D is equals to 2r. Why do we say 2r? Because we say the radius is half of a diameter. The radius is half of a diameter. In this case that we are given, you can still calculate this using the radius. Remember that we said alternatively, not pi d, you can use 2 pi r. So what can you do? You can still say circumference is equals to 2 pi r, which is going to be 2 times pi times, remember in this question you are given the diameter, and what we say the radius is, it's half of the diameter. So it's going to be 5 divided by 2 to find your radius, which is half, which is going to be 2.5. So it's going to be 2 multiplied by the pi multiplied by 2.5, which is your radius. So when you come to your calculator, you press your 2 multiplied by the pi multiplied by the 2.5, which is your radius, which is going to give you, still give you 15.7079. This is to show you that both formulas give you the same answer. So we alternatively gave you the radius one to show you that not all questions are going to come giving you the diameter only. Some can come just giving you the radius. So you can work with both, knowing what the diameter is and knowing what the radius is. So if it's given like this and you use the diameter one, it's going to be wrong. Why? Because this 3 centimeters is not a diameter, but it is a radius. So I hope you have got that. And then we have what you call the arc and the sector. Remember what we said an arc is. What did we say an arc is? We said an arc is a portion of a circumference. We said an arc is a portion of a circumference. And what did we say a sector is? What did we say a sector is? We said a sector is a part of a circle that is enclosed by 2 radii. That is enclosed by 2 radii. So a question is going to come giving you just a circle like this. And what is it going to do? It's going to give you part of an arc. It's going to give you an angle which can be 30 degrees. And then what is it going to give you? It's going to give you the length of this part, which can maybe we can say 3.5. So when a question comes and say, we want the length of an arc. What is the formula for the length of an arc? The length of an arc is equal to the sector angle. We already know what a sector angle is, over the revolution multiplied by the circumference. So the formula is theta over 360, which is our revolution, times pi d, or we can say theta over the revolution times 2 pi r. Right? Why do I have 2 formulas again? Remember, we alternatively use 2 formulas for circumference. We have the pi d one and we also have the 2 pi r one. In this case, when you're not given the diameter, you can use the one for the radius. When you're not given the radius, you can use the one for the diameter. So, in this case, our question that I've written for you there is a circle, and your sector angle is 30 degrees. Your radius in this case is 3.5. So if a question comes, says, what is the length of the minor arc? What is the length of the minor arc? What are you going to do? You're going to say, remember we said it's a sector angle. What is the sector angle in this case? It's 30 degrees. Our revolution is always 360 degrees. Multiplied by our, remember here we're going to use the radius formula because we are given a radius. So it's going to be multiplied by 2, multiplied by pi, and multiplied by our r in this case, which is 3.5. So, in your calculator, what are you going to do? In your calculator, you're going to say 30 over, to be quite frank, some of you don't know, you can just press this value in your calculator and it can give you a different answer rather than when you have simplified it. What am I talking about? Let me press 30 over 360 times 2 times pi times 3.5. What is it going to give me? Sorry, 30 over 360 times 2 times pi times 3.5. What is it going to give me? It's giving me 1.8325955715. But what if I've simplified this 2 times pi times 3.5? And I say multiply by 30 over 360. It's still going to give me the same answer. But I advise you to always at all times try to simplify where you are able to simplify, right? So our answer in this case is 1.83259571.5. Sorry, 5715. So remember, all our values should be to 3 significant figures. So how is it going to remain? It's going to remain as 1.83, which is going to be our length of our arc. So in this case, I didn't put any units there. If I had put in meters here, I would just say 1.83 meters, right? But if I put in centimeters there, I would just say 1.83 centimeters. So your units are going to be dependent on what the units were given there. So now we know how to find length of an arc. Next, this is length of, okay, it's still fine. This is the length of the minor arc. Remember, this is the minor arc, it's just the small one, right? We have the big one this side. So what if they said we want the length of the major arc? Find which arc they want, right? So in this case, we have the length of the minor arc. What if they said length of the major arc? What are we going to do? We already have the degrees of the minor arc, the angle of the minor arc. So what are we going to do to find the angle of the major arc, which is this side? Right? What are we going to do? What are we going to do? We're going to say, we're going to say 360 minus 30 is going to give us 330, which is going to be our angle for the major arc. So what are we still going to do? We're going to say 330 over 360 multiplied by 2 pi times 3.5. What are we going to find? We're going to find, if you press your calculator, this applies to both this is mostly at paper 3, but it's also at paper 2. So it's better you learn and not say this is paper 3 material. Times 2 times pi times 3.5, which is going to give you 20.15855. To 3 significant figures is going to give you 20.2. So this is going to be for your major arc. So now we know how to find the length for the minor arc and for the major arc, which is good. We're one step closer. And then we have what you call area of a sector. What is the formula for area of a sector? Area of sector is equal to the sector angle over the revolution multiplied by the area of a circle. So you can see the difference in the length of an arc and the area of a sector. What is the difference here? The difference is this one you multiply by the circumference. And what did we say the circumference is? Distance around the circle. And this time we have learned a new value which is called area of a circle. So how do you find the area of a circle? The area of a circle is equals to pi r squared. The area of a circle is equals to pi r squared. So if you're given a diameter, you're going to have to change that diameter onto a radius. What are you going to do? You're going to divide it by 2. Why? Because we say a radius is half of a diameter. So this is how we calculate our area of a circle. The area is equals to pi r squared. Right? So in this case, they're saying area of a sector. Right? So what are we going to do? Still using the same question. We're going to say our sector angle in this case is 30 degrees. Our revolution is 360 multiplied by the area of a circle. What is our area in this case? We can calculate it this side. Is equals to pi r squared, remember? It's going to be pi. Your radius is going to be 3.5 squared. I hope you've learned the squared at numbers there. When you're doing numbers, you know what square is. Square, you're saying we're multiplying that value by itself. Not by 2, but by itself. So, when you press your calculator and say pi multiplied by 3.5, what are you going to find? 10.99557429. So you don't need to change this to 3 significant figures. You only need to change your final answer to 3 significant figures. So it's going to be 30 over 360 multiplied by 10 when you use the whole value that you already given, that you already calculated, sorry. So it's going to be 30 over 360 multiplied by 10.99557429, which is going to give you 0.916297. Right? It's going to give you. Oh, sorry. I think I've made a mistake here. Area of a circle is going to be your pi multiplied by 3.5 squared. 3.5 squared. Why did I get a wrong answer there? I didn't square my 3.5. Where do you square your 3.5 in the calculator? There's a y-x there. There's a square root there. The next value is the square. That's where you square your calculator. So it's going to be pi multiplied by 3.5 squared, which is going to give you 38.48451001. 1001. So these are the mistakes you're going to be making in your papers. So make sure you square, as you already saw that I forgot to square my 3.5, and I had to realize that by seeing how my answer was, right? So pi multiplied by 3.5 squared is going to give you 38.48451001. So that's the value we're going to use here, because we're saying our formula is sector angle over revolution multiplied by an area of a circle. So it's going to be 30 over 360, and our area of a circle that we have already found, it's 38.48451001. We're going to multiply this by, which is going to give me 3.207042501. So I hope you are finding the values I'm finding here, because I hope we're using the same calculator. Some of you maybe might be using a Casio calculator, which is still fine. So we're going to change this into 3 significant figures is going to give us 3.21, which is going to be your final answer. So now we have talked about all the questions that can be asked in your circle. You can be asked to calculate the circumference of a circle. You can be asked to calculate the diameter of a circle. You can be asked to calculate the arc and the sector, which is the length of an arc and the area of a sector. So these are a lot of formulas that you should know by head. You should know them, because they're not provided onto your paper. So please study these formulas and know them. So next, we're going to talk about the cone, the pyramid, and the sphere. We're going to talk about the cone, the pyramid, and the sphere. So, on the cone, the pyramid, and the sphere, we're going to learn about 2 things. We're going to learn about the total surface area and the volume of all these. So what are we going to do? We know a cone, a pyramid, and a sphere. I've already drew them here. This is the cone. The cone. How can you know a cone? Maybe the party hats that you wear there, the parties, like at the baby's parties, that it's the cone. And then we have the pyramid. Here is our pyramid. So a pyramid, we have what you call a triangular-based pyramid and a square-based pyramid. And then we have what you call a sphere. So on these, we're going to learn how to calculate the total surface area of all of these shapes, all of these solid shapes, and we're going to learn how to calculate the volume of all of these shapes. So in your paper, in all of your papers, your paper 1, your paper 2, and your paper 3, you are given these formulas, the total surface area of all these formulas, and the total surface area of, and the volume of all of these. So, except for the pyramid. Why? Because we have what you call a square-based pyramid, and we have what you call a rectangular-based pyramid. So what are we going to do? We're going to learn and we're going to know the formulas for all of these three shapes. And we're going to learn the volume, how to calculate the volume for all of these three shapes. So now let's start with our cone. Let's look at our cone and let's assess our cone. How is our cone? Our cone, as you can already see, it's made up of a circle down there. It's made up of a circle down there. As you can already see, maybe some of you have cones in your book that you are holding there. We have a circle and we have this shape around here. You see, it's kind of like a triangle, but no, it's a circle. Okay, so how are we going to do? Our formula for the cone, to find the total surface area of a cone, it says total surface area is equals to the pi r squared plus the pi r l. Our r in this case is our radius. And our L in this case, we call it the slant height. The slant height. The slant height. You see this height, it's slanting. That's why we don't say it's just a height. It's slanting. So that's why we call it our slant height. So as you can already see, the height, which is here, you already see this one. This is my height, this is my radius, and this is my slant height. Right? So my height here and my radius, you see, when they join, they make a right angle. So the Pythagoras Theorem that we're going to learn maybe on our last lesson also can be able to calculate this. So our Pythagoras Theorem just says L squared is equal to the r squared plus the h squared in this case, right? So there's another one that you are going to learn, and we're going to cover more on the Pythagoras Theorem. So right now all you're going to have to know is the pi r squared plus the pi r l. And then we have the volume, the formula for the volume. The volume of a cone. What's the formula for the volume of a cone? The volume of a cone is 1 over 3 multiplied by the pi multiplied by the r squared multiplied by the height, which is our formula, our volume here. So this is our two formulas. To find the total surface area of of the cone, it's pi r squared added by pi r l. And the volume of this is 1 over 3 multiplied by pi multiplied by r squared and multiplied by the height. Let's rush on to our pyramid. We don't have, like I said, we don't have the total surface area of a pyramid because we have two types of pyramid. The first pyramid there, what do we have there? We have a square-based pyramid. This is a pyramid that has a square at its base. And then we have a rectangular-based pyramid. Also these ones, Pythagoras Theorem applies because we have right angles. We have right angles. Right. So Pythagoras Theorem only works on a right-angled shape. And then we have what you call the what? Oh, we say the volume is equal to 1 over 3 multiplied by the base area. Remember, the base can be a triangle, the base can also be a rectangle. That's why we say base area. So if it's a rectangular base, it's going to be the area of that rectangle there. And if it's a square base, it's going to be the area of that square, right? Multiplied by the height. multiplied by the height. So this is going to be our volume, how we're going to find the volume of a pyramid. Now let's rush onto a sphere. Let's rush onto a sphere. So these formulas, remember these formulas are given to them in all papers. So that's the lucky part. So this is a sphere. This is how a sphere looks like. So the total surface area of a sphere is going to be, 4 pi r squared. And the volume is going to be 4 over 3, pi r cubic. You see something new has just popped up. We have cubic. What do we say cubic is? We're multiplying that number by itself 3 times, right? So that's the cubic part. We're multiplying that number by itself 3 times. So not all questions are going to come as a full sphere. We have what you call a hemisphere. What is a hemisphere? A hemisphere is half of a sphere. So sometimes it's not going to be a full sphere, it's just going to be like this. And this is what you call a hemisphere. Right? So a hemisphere is going to now change your total surface area. We have a total surface area of a hemisphere. A hemisphere is just half of the sphere. Right? So what is the formula for, what is the formula for a hemisphere, the total surface area of a hemisphere? What are we going to say? It's going to be total surface area is equals to 3 pi r squared. Right? Why? It's just half of it, right? Yes, it's just half of it. So remember, a hemisphere is made up of this circle that is on top. Remember how do we calculate an area of a circle? It's pi r squared. And half of this kept surface area we calculated as 2 pi r. Calculated as 2 pi r. So remember, look how a hemisphere is made up of. You can see. So when you're going to calculate the total surface area, it's going to be this, and by this, we should give you 3 pi r squared. I hope you get that. And then, sometimes this hemisphere, I think we all know a bowl, right? A bowl sometimes cannot have anything inside, right? So when it doesn't have anything inside, now it changes. A hollow one. Something that is hollow is something that doesn't have anything inside. So the area of a hollow hemisphere is going to change now. It's not going to be 3 pi r squared, but the total surface area is going to be 2 pi r. You see that this pi r squared comes from the circle inside there. The 2 pi r, it comes from the kept surface area there, right? So when we don't have that top part, when it's just hollow inside, it's going to be 2 pi r. But when it's a solid hemisphere that has something inside there, it's going to be 3 pi r squared. So I hope you get that. So the volume for all of these three items is not going to change. The volume remains the same. You're still going to use 4 over 3 multiplied by pi r cubic. So I hope for all of these you can attempt paper 3 and paper 2 questions. Thank you. Welcome back to the mensuration, the continuation of the mensuration lesson. So today we are going to be covering prisms and density, mass and volume. So let's start off with prism. What is a prism? A prism is a 3-dimensional shape that has a cross-section along its length. That has a cross-section. What can we say a cross-section is? A cross-section is that part that when you cut, it's exposed, right? So we have 3 prisms. We have the triangular prism, the cuboid, and the cylinder. So the triangular prism, it's made up of 2 triangles and 3 rectangles. So how many faces does it have? It has 5 faces. So 3 questions can be asked in Prism. You can be asked to find the surface area of the cross-section, You can be asked to find the total surface area, and you can be asked to find the volume. So the surface area of the cross-section is going to be the area of wherever when you cut, it's going to be exposed. So it's going to be the area of the cross-section of the shape. The total surface area is going to be adding the areas of all of this shape. And the volume is going to be the cross-sectional area multiplied by the length of a prism. So, when we go to the cuboid, the same questions are also asked. So, the cuboid, the surface area is going to be, or the surface area of a cross-section is going to be the area of that rectangle because it's made up of a rectangle. The total surface area is adding all those rectangles. As you already know, a cuboid has 6 faces. 1, 2, 3, 4, 5, and 6 at the bottom. And the volume, you still use the same volume, cross-sectional area multiplied by the length of a prism. Cross-sectional area, which is going to be the area of one rectangle. So I hope you get that. And then we have the cylinder. The area of a cylinder is here. 2 pi r squared plus 2 pi r h. So the volume is going to be the area of a circle multiplied by the height. The area of a circle multiplied, because when you cut the cylinder through, what's that shape that is going to be exposed? The shape that is going to be exposed there is the circle. Just as you cut your triangular prism, the shape that is going to be exposed there is your triangle. So remember, your surface area of a cross-section is going to be the area of a triangle. In this case, is going to be the area of a rectangle, and this case is going to be the area of a circle. When they say total surface area, remember you add all the shapes that are there, remembering the faces that you have there. You have 5 faces here, you have 6 faces here, you have 2 circles and a rectangle here. So the volume of the prisms are always the same. It's always cross-sectional area multiplied by the length of a prism. In this case, it's going to be the area of a rectangle multiplied by the length, the area of a triangle multiplied by the length, the area of a rectangle multiplied by the length, the area of a circle multiplied by the length. So I hope you got that. Now let's move on to the density, mass, and volume. So what is the density? Density is the mass contained per unit volume of a prism. What did I say? Is density is the mass contained per unit volume of a prism. And it is obtained by the formula that I've stated here. Density is equals to the mass over the volume. So maths is always tricky. Sometimes it can tell you, it cannot give you the volume. And you're going to have to find the volume, maybe the volume of a cuboid, before you actually calculate the density. So if a question comes and just says, calculate the density, but you only have the mass, you don't have the volume. What are you going to do? You're going to calculate the volume of whatever shape that you're given there. So thank you. This is the end of mensuration lesson. I hope you enjoyed it.